Beats by Scientist.
What's up, folks? Today we're going to do Jacobeans, you guessed it. We're going to look into a more difficult question one. So we're going to find the volume of an ellipsoid. Sounds interesting, right? Let's break it down to you. Okay, I've seen some complaints, like there's a book which I saw earlier on, which was very long on its calculation, but the answer is true. So let's look at an ellipsoid. So what we're going to do is, this is an ellipsoid. It's like egg-shaped. It's egg-shaped. Okay, we're going to do transformation into Jacobian to transform the egg-shaped shape into a circle, into a sphere. Into a sphere. That's called Jacobian transformation. Okay, sounds difficult, right? I know. So let's make it easy for you. Let's make it easy for you.
Alright folks, this is the question we're going to do. It's x squared over x squared plus y squared over b squared plus z squared over c squared. This is an equation of an ellipsoid where the bounds are a squared, b squared and c squared. So we're now looking at how to solve this kind of situation in our own plan. So for us to do Jacobian, we need to transform this type of ellipsoid into a circle, into a volume, into a sphere, so like as we said before. So how do we do that? Okay, by using substitution. Okay, let's express x in terms of u and y in terms of v and z in terms of w. So x in terms of u, y in terms of v and z in terms of w. So let's see. Let's start with x. X is equal to u a y u a. I expressed x in terms of u and a constant a, and this, if we substitute this into our original equation, a is gonna cancel with this bottom a part, just like y for y is equals to uv b and z is equals to wc. They'll just cancel the bottom terms. So substituting here, x squared over a squared, since x is equal to u over a of squared, it's similar, it's nothing changed there, plus y vb over b squared plus z is wc over c squared. Here is they cancel a and a, b and b, and also c and c is equals to 1. Let's not forget that. It becomes u squared plus v squared plus w squared, which is equals to 1. Now, what is this thing? This is an area of a circle, right? This is an area that's like volume of a sphere. Sorry, it's the equation of a sphere. Okay, with the radius root of 1, which is 1. Okay, now what do we do? Remember, if we did the substitution here, this is our substitution. Now for Jacobian transformation, we have to differentiate dx in terms of u, in terms of v, and in terms of w. It's a partial derivative in terms of u, v, and w, and y also in terms of u, v, and w, and z in terms of u, v, and w is a partial derivative, and we have to find the determinant of those. So how do you do? It's like dx, partial derivative of dx in terms of du, and also dx in terms of dv, and also partial derivative of dx in terms of dw. Let's elongate this, alright. And also we do the same dy in terms of du, partial of dy in terms of dv. Remember, these terms are a bottom line, and also dy in terms of dz. And what if z also? So it's dz in terms of du, dz in terms of dv, dz in terms of dz. Okay, that's no worries there, we'll fix that. So let's expand it down like this. Exactly. Okay, let's go. Dx in terms of du. Where do we go here? We partial derivative of dx in terms of du, which means it's a, right? Dx du, it's a. Dx in terms of du, dx into, yes, dx du, it's a, right? So we write down a in the first column, corresponding to what this. Then dx dv it's 0. So we write 0 in terms of the column, and also dx dw is also 0. So it's du dv. Sorry, dz in terms of dw, it's dw, sorry. A is 0. Okay, now the second column, second row, dy du, here dy du, which is 0. Then dy dv, which is b, and dy dw, which is also 0. Then we go and the third column, which is this one, dz dw, no, we are starting with u, so we are in the youth column, dz du, which is 0. Now we are in the dz dv, which is also 0. Now we are in the dz dw, which is c. So what's the determinant of this thing? The determinant, you can find it is just equals to a, b, c. We did differentiation of in terms of du, dv, and dw. That's why we do. So it's abc du, dv, dw. That's our Jacobian for this transformation. So it's like now, it's now like this: double integral of a, b, c of du, dv, and dw. Okay, here is our equation of u squared plus v squared plus w squared is equals to 1. Okay, now we want to do a more complicated way. This seems like a complicated if you want to do in terms of u and v. So what do? We can convert these things into spherical coordinates. If you don't know first spherical coordinate, comment below or get my number. I'm free, I can talk to you and help you, and I know how to do it. So let's do like this. Just imagine this. Okay, that's not okay. Imagine this line and another line and another line. So then my line is not perfect, but it's okay. I call this u, I call this v, I call this w. We've drawn this thing. Okay, just imagine like this is a radius called rho. Okay, this angle between the w and our radius is phi, and if we project this down into the plane of VU plane, this is a VU plane. Okay, the angle between this and this is called theta. Okay, how do you go about it? Now we want to express, since these are spherical coordinates, we want to express W, U, and V in terms of phi, rho, and theta only. So how do you go? Let's start with W. W is equals to, look at here. This is a projection in a 98 degrees, 90 degrees. So rho cos alpha, that's where we get this since this is an hypotenuse, so it's rho cos phi. Okay, now we want to project, to find the u. Who's u? Okay, from here to here, the answer is since horizontal projection is the b cos alpha, so from here to here it's b sine alpha. That's b sine or that's the projection from over here to over here. That's 4 sine so sine the angle between here and here. Okay, so what about from v? What about from here to here? That's u. Okay, let's go, since this theta, so let's go this 90 minus theta. 90 minus theta, the angle between here and here, since over here to here it's theta, so it's, since this is a 90-degree angle, this is a 90-degree angle from here, so this means from here to here it's a 90 minus theta. So u is equals to the projection p sine alpha, p sine is into that's projection, that's cos 90 minus theta, the angle between here. So the angle here in this direction, in the v direction, this is in the u direction, in the v direction it's v is equals to p sine alpha, p sine cos sine 90 minus theta. Remember from our laws, u is equals to p sine rho sine so guys, I'm big. Just went for a small snack break. Going to try and okay, let's go. So it's p sine cos 90 minus theta becomes sine theta, and v is equals to sine 90 minus theta becomes cos theta. Now we have, these are now substitutions. Okay, you can go using Jacobeans in terms of p, if in terms of rho here and this. You do a Jacobian transformation, but what you will get is this thing. You get rho sine squared sine of omega d theta d omega and dp d rho. These are equal. Okay, so without further ado, let's write it down like this. It becomes like this, and d rho. Okay, now we need our bounds, our regions. Okay, how do you find them? Let's get back to our equation. Remember, u squared plus v squared plus w squared is equals to 1. This is, it's like root of 1 is equals to 1. So this is a circle. This is a sphere of radius 1, right? So if we get back to our this, we need like from dp, this is the last integral, that means here, so we're going from 0 to 1 our radius, since it has been, we have transformed an ellipsoid to a sphere, so that's why now we're taking it as a sphere. So in this direction, okay, let's get back here. In this direction, this is the w's direction, right? This is phi. So from here we are going in 180 degrees to here to see how. So this is from 0 to pi because we need from this to this. Okay, so it's from 0 to pi. What about in this direction? In theta direction, we need the whole area of the cycle, the whole area. That means we need the whole revolution, which is to 2 pi. So it's from 0 to 2 pi, just like this. Now we're simple integrating. Okay, what you are going to do, we're going to differentiate the first term in terms of theta only, like this. So this becomes 1/0 of pi to 0. This is an integral of p squared sine phi of theta. These are the product from the limits 0 to 2 pi. If we substitute, it becomes 0, pi, and 0. It's like from p squared sine phi 2 pi times 2 pi minus, obviously it's 0. So it becomes 1/0 from 0 to pi of 2 pi. Remember, this is since we did in terms of theta, so now we're left with d phi dp. So it's 2 pi p squared rho squared sine phi. Okay, now we're good. Now we're integrating in terms of d phi dp. So now we're in this column right now. So in terms of phi, this becomes 1/0 of 2 pi p squared. Since in terms of phi, this changed into cos phi. In terms of dp now, since so it's from 0 to pi. Okay, so this becomes 2 pi squared cos pi minus 2 pi squared cos 1 cos 0. So it's from 0 to evaluate this, we count 2 pi squared times, what is the cos of pi? Cos of pi, it's -1 minus 2 pi squared cos of 0, it's 1. Now we see, right? This leaves us with integral from 0 to 1 of, if we evaluate this, becomes 2 pi squared minus 2 pi squared minus 2 pi squared. It becomes minus 4 pi squared. Is it correct? Minus 4 pi squared minus 4 pi rho squared, sorry, in terms of d rho. So if we differentiate the integrate this, it's 4 pi of rho cubed over 3 is from 0 to 1, and this becomes -4 pi rho. Since we're now evaluating, this becomes 1 cubed over 3 minus this 0, so it becomes 4 pi over 3 4 pi over 3. Okay, this is not the answers. Why it's not the answer? Because remember, from our first integral, first ABC was a constant. So what we did simply just did was to factor out ABC. Then we did the integration of rho squared sine phi d theta d phi of dr. So these were constant, so that's why we factor out is constant, so that's why we didn't consider them at all, so no worries. So here we simply multiply by a b c, so this becomes 4 over 3 pi of a b c, and that's the volume of your ellipsoid. Okay, thank you folks.
Yeah, this was interesting, huh? That was a bit interesting, like this was a long story, so now we get to the final point. So subscribe, don't forget to subscribe and share the content with your friends. My name is Wayne, scientist here. As you know it, I came from something different, so like, subscribe, don't forget to subscribe and tell your friends that there's a guy who can help you. So you can contact me, my number, and post some questions so I can work out that for you, like someone just did over there. It was someone's question, so I had to work it out. So post some questions. This is my number below the description in the link, and scientists, my videos like this are coming soon, so don't forget to subscribe. Subscribe. I'm waiting for you to subscribe. This video is not ending until you subscribe, so it will automatically just finish until you just hit the subscribe.